All right, we're going to kick this off and get started. Appreciate everyone coming out at the second day of build. So how's build going for you so far? Pretty good? See a few heads nodding. Awesome. I'm going to talk to you about an Azure service that literally will connect pretty much anything to everything. And I'm going to prove it by connecting a few things to a few other things live in front of you on conference Wi-Fi, no less. So hopefully that will go good. What could possibly go wrong? My name is Jeremy Lickness. I'm a cloud developer advocate here with Microsoft. And I've been a professional developer for several decades now, which should probably stop bragging about too much because it's getting up there in years. But I've seen a lot of changes. And more so than ever, we're a connected world, right? So we have events coming from Internet of Things, from our laptops. I'm pretty sure if I was a kid and you told me that a vending machine would be connected to the internet, I'd look at you and go, what? That's crazy. And then I'd say, what's the internet? Is that something like the metaverse? So a little bit of an age joke. It's complicated to manage all of these events. Now, I've been through that process of actually building an eventing system myself. And this involves standing up multiple machines. We used journaled messaging. We used SQL Server. We used Windows services. And at the end of the day, there was probably more time spent setting up the infrastructure for this than there was almost writing the code to send the events. Has anyone been on a project like that where you've had to build your own eventing system? I see a few hands. So it would have been nice, right, back in the day if we had one place where we could manage all of our events. And that's what I'm going to talk to you about today, which is Azure Event Grid. So Azure Event Grid is a serverless platform. It means I don't have to deal with a virtual machine. I don't have to configure a cluster. But what I get out of this is all the things I'd want to see for events. I get event routing. I get real-time event delivery. And we call it near real-time. I'll talk about what that means in a second. We get massive scale. I'll tell you what the scaling numbers are. And we get coverage both inside Azure and outside. I'm going to show you both of these because Event Grid makes some pretty amazing things light up inside of Azure, but it's set up so that you can build and publish and consume events even completely outside of the Azure system. We'll see what that looks like. But basically, this can be a backbone for all of the events that you're driving through your system. So some of the benefits you get, obviously focusing on innovation. If I'm not configuring clusters and servers and standing up infrastructure, and I'm literally just paying, I think the latest that I saw for pricing is 60 cents per million events. So I'm just paying per events that go through the system. I've got reliability and performance really guaranteed to me from the platform, and this allows me to enable a lot of different scenarios. But the biggest benefit is really this management of events in a single place. So what does that look like? First thing I want to talk about, who here is familiar with event hubs, just out of curiosity? So I get a lot of confusion about, we've got this new Event Grid service. How does this relate to the other services that are in Azure? So Event Hub is something that you can think of point-in-time data. So this is a lot of streaming data, and you would go out and pull data and look at data for a window of time. This is something that you can replay back, and you're dealing with a lot of data points. On the other hand, we've got Service Bus, which is where our critical, mission-critical messaging system comes into play. There's transaction-based parameters that you can wrap around your messages. You've got workflows and routing, so there's a lot of advanced scenarios for that. Event Grid sits right in the middle. Event Grid is designed for the business logic in your application. I'll talk a little bit about the types of messages, but it's a push, not a pull, and that's important. You don't actually go out to Event Grid and ask it for a message. Event Grid figures out where you want to receive these events, and it pushes it out to you, and then guarantees that delivery for those messages. So it's a different model. You can have multiple handlers to handle messages that come through, and you get ordering of events. So you get a few things that you'd like. So let's talk about the scenarios of applications that we can build with that. So one of them is serverless applications. So between Azure Functions, between some of the database offerings, between Event Grid, this can actually glue components of your application together. So anything interesting that you want to respond to that happens in your application architecture is something that you can route through Event Grid and do it in a serverless way. Again, not provisioning your own servers or clusters or infrastructure for this. There's also a big piece of ops automation. So when you create assets within Azure, like subscriptions or resource groups, this will trigger Event Grid events, and then Azure automation can actually consume those events and do things. So whether it's auditing, whether it's provisioning certain types of infrastructure, all of this can be rolled into the Event Grid experience. And the other piece is application integration. Because of the open standards that I'll show you, Event Grid makes it possible to send events from your legacy applications and consume events by those applications as well. As long as it can connect to the web, it can receive a message from Event Grid. So I touched upon this sort of serverless application platform, and I want to talk about Azure's serverless platform for a second. Anyone here familiar with functions, just out of curiosity? It's been talked about a lot. So this is really the code you write that responds to events. And then we have logic apps, which is our orchestration. This is how we connect different services, we compose workflows, and we have processes that move through the system. And then finally, Event Grid is the messaging conduit that sends those interesting messages between all of these different endpoints. So I can consume Event Grid from logic apps. I can consume Event Grid from functions just as easily as from my own application. So this, of course, sits across the whole suite of services that you've been hearing about here at Build and integrates with your IDEs as well. So managing events from one place, there's really two sides to this equation. On the publisher side, what's interesting about Event Grid is Azure resources automatically publish events. So those events are automatically broadcast for you to listen to, and I'm going to show you what that looks like. You also have custom events, so you can write your own code to fire off these events. On the right side of the spectrum, as far as consuming events, there's built-in Azure resources that'll plug in and receive event notifications, and there's also a webhook standard that allows you to write your own receivers for that. Configuring this in the system is as easy as going into the portal, picking the type of message you want to listen to. You can filter this out. So for example, if you have an image processing program, you might only listen for events that have an image suffix on the file name, and then you send it to a handler that processes that event. So I talked about reliability and near real-time messaging. Near real-time is sub-second at the 99th percentile. So this is not something you'd have on a conveyor system that needs to route within milliseconds, but anything that's within a second of fidelity, so between it happening and you being notified, is fine for Event Grid. When we talk about scale, it'll handle 10 million events per second per region, and you can scale to multiple regions. And then when we talk about reliability, Event Grid will continue to send that message to your handler for a 24-hour period. So once you receive the message, we're good to go. But if for some reason your code is down or that handler's down, it'll continue to retry and guarantee that delivery in a 24-hour window. After 24 hours, it gives up and no longer considers that to be a valid subscriber in the system. And I'll show you a little bit what that looks like. So these are some of the highlights I just wanted to call out. In addition to high availability, 100 million subscriptions per region supported by this, and a 50 millisecond publisher latency. So that's the time between you send the message out and get confirmation it's being routed through the Event Grid. Now, I'm going to jump into a demo and show you connecting things to other things in a second, but I want to just level set on terminology. So an event is the thing that happened. The event publisher is where it happened, so the source of the event. The topic is where the publisher sends events. So these are like channels, right? So you can have topics that have different types of interesting messages flowing through those. You have event subscriptions. This is how you receive events. And then the handler is what actually reacts to the event. So the subscription is responsible for getting the message to you, and then your handler is what will process that message. So showing what this looks like natively in Azure, I've got a build Event Grid storage. So this is just an Azure storage account. Now, automatically, without me doing anything special, I have this events tab that's going to show me the different ways I can consume events coming out of this. And we've got logic apps, we've got cognitive services, we've got a lot of different consumers. The way this works is in my blob storage. We'll go back to the overview, go into blobs. I create a container called build that I'm going to upload something to. And let's say I want to have an application respond to those uploads. So what I would do is, in this case, I've set up a function app. Now, this function app is just a host for function endpoints. I haven't actually created an endpoint yet. So what I'm going to do is click this plus. It's going to let me create a new endpoint. And then we're going to come down, choose custom function. And then we can search for a trigger. I'm going to look for event grid trigger. And I'm going to do this in C#, give it the default name. And this is going to create a simple Azure endpoint that's designed to listen to events. So if we take a look at that, you can see it basically gets this event grid event passed into it, and it's just logging it out. That's the default behavior for this. Now, right now, it can listen to any event. I haven't actually created a subscription yet. So I'm going to go ahead and do that, add event subscription. And this is going to let me pick what's the name. We'll call it event build receiver. It's going to give me a topic type. The topic type that I'm interested in is storage. We'll pick a subscription. That's the account, so that they know where to send my bill after I give this presentation. We got the instant, which is build event grid storage. And I'm not going to filter anything. I'm just going to subscribe to all event types. So I'm going to click create. And that's going to actually provision the subscription. So I've got a handler that I just wrote as a function. And actually, the template wrote most of that for me. And I just created a subscription to listen to it. So what we'll do over here is we'll click this upload button. And I'm just going to look for a random file to upload. So let's see what we can do here. And it looks like I actually have a random file. So we'll pick that one. Click OK. And we'll click upload. So that's uploaded. Let's go over to our function. And now what we see here in our function is we've actually had an event trigger that gives me information about that event that just happened. So I'm going to pull out of here and just clear that, come back out, and this time I'm going to close this dialog, and I'm going to delete the file. So we'll go random file delete. We'll click OK. Come through here, and we immediately get an event that gives us the information about deleting that. So that's as easy as it is to hook two Azure resources together through Event Grid. Now, as a brief summary of the guiding principles behind what you just saw, the idea is that the service attempts to be always available. There's 99.99% availability. Near real-time event delivery, we talked about that sub-second. At least once delivery. And we just saw the automatic topics with Azure resources. However, Event Grid's designed to be platform agnostic. And so through the webhook standard, we can write code that publishes and consumes events, all using the same platform. And I want to show you what that looks like. So the first thing is just a quick aside between a command or event. So a command is something that says do stuff. And that's most likely something I might send through Service Bus to make something happen in a transactional basis. I may have to have 15 things happen at the same time orchestrated based on a command. Event Grid is really for events. This is stuff happen. This is an FYI about the system. You can still trigger logic and process things, but you wouldn't want to have the same type of code dealing with a command. So do stuff versus stuff happen, sort of FYI. Now, inside the Event Grid event, and I'm showing you the legacy schema, and I say legacy because just yesterday there was an announcement that Event Grid now supports what's called Cloud Event, which is an open eventing standard. So there are actually multiple types of schemas this will support. But in general, we get a topic, which is that channel that the event's going to. We get a subject, which is what the event's about. We get an ID, which is a unique identifier for that event. We get an event type. So the event type is interesting because we might have different payloads inside of our event. So I might have different information for an image upload compared to an image delete or a modification. So I can have a different type to serialize and parse out that information. I get a time so that I have ordering for my events, and then I have the unique data. So what I've done is created just a custom message system that I'm going to show you called build messages. And so the subject is really just the message. We get event time, and the data is just the message payload. Now, to create that in code, and here I'm showing C# code, I've written a cross-platform .NET Core app that basically just sets up a payload with all the parameters that Event Grid's expecting. So we set a unique identifier, we give it an event type, we set the message payload, etc. To send the event, we're really just using an HTTP client, and we're posting to an endpoint. So it's very straightforward. There's nothing special I need to do except setting a key in the header. So you can see there's an AEG for Azure Event Grid SAS key. I get that key from the portal. I'm storing it in my environment variable so I don't have to share it with everyone. But that'll be set in the header and posted so that I can authenticate that I'm allowed to send the event. To receive the event, I've built a web API project. So this is just a web server that's listening on an endpoint. Now, to prevent using Event Grid from spamming an endpoint, for example, I don't want to just plug in anyone's web address and start firing off events. There's a handshake that happens to validate that you're a valid handler. So what happens is the very first time when you get a subscription, you get a unique code, and you echo that code back and say, yes, I can receive messages. Once that happens, then you're a channel to start receiving those events. So this is the code using the SDK for Event Grid that literally says, is it this special event type? If it is, echo back the validation message. If it's not, I can literally just pull the message data off of this and go to work with that message data. So let's take a look at that. What I've got here is a console that's running because I took that web app and I put it in a Docker container and I published it to Azure using web app for containers. So this is up and running in Azure, and I can take a look at my log files to see what's going on with this container in Azure. If we look at the log files right now, it's nothing very interesting. It's just listening on port 80. It's waiting for something to happen. So what we're going to do is come into our portal here, and all I had to do to create this custom topic was just hit a plus in the portal. So I want to create a custom topic called build messages and set that topic. That's all I did to create this build messages topic. So now this is ready for me to send events to and subscribe from. So what I'm going to do is add a subscription. I'm going to call it Event Grid Receiver. We'll make sure that's valid. I'm going to get all the endpoints. And I'm going to type in eventgridreceiver.azurewebsites.net API build. So that's the fully qualified domain name. I'm running a web API, and the controller is my build controller, so that's where I want the message routed to. So I'm going to click create, and the first thing it's going to do is it's going to go out and send that validation code and make sure that my endpoint is ready to receive these messages. So it's actually hitting the web app that's running up here in the cloud. So if we look at our logs one more time, let's pull those up. And you know this trick, right? If we move the mouse clockwise, it speeds things up. Okay, great. So what we did was we received the event, and then we validated it with the token. So I echoed it back. So now I'm ready to receive messages. So I'm going to pop over here, which is just a bash for Windows. I'm not actually on a Linux machine. I'm on my Windows machine, but I like using this terminal. I'm going to type, just so you see, I'm inside a directory that just has a program.cs file. It's a .NET Core app. And I've already set my tokens and my environment variables. So I can do .NET run. This is my first Event Grid message at build over conference Wi-Fi. Fingers crossed. Let's try that. So we'll let that run, spin up for a second, and we get a success message. So this is just echoing back the payload it created, and it said the response was fine. So I'm going to take its word for that and come back over here, and let's just clear and look at our logs again. And if everything went well, we get this message here, received event with type build message. This is my first Event Grid message, yada, yada, yada. So that was live, endpoint, conference, Wi-Fi, Event Grid. You just saw it inside Azure outside. Pretty cool. Anyone impressed? A little bit of love? A little bit? Thank you. All right, so just to recap, the idea here is serverless events, and I know everyone hears serverless all the time. It's a great term, but what I see serverless to mean is two things, really. One is obviously less server to deal with. I'm not provisioning a virtual machine. I'm not dealing with a cluster. But the other is I'm paying for use. So if I'm not sending events through the system, I'm not paying for it. When I am sending events through, I am. We can massively scale. You saw how many tens of millions of messages it can handle. We've got reliability and delivery, so that's all handled for us. I don't have to use journaled messaging queues. This is doing it for me. And there's integration both inside of Azure, which we saw with connecting the endpoints, and outside of Azure through the webhook and publishing your own messages. So that's what I have for you today. Please evaluate the session. Your feedback's valuable. And I will actually be here for the entire event, hanging out in the lounge area. If anyone has questions for me about this, would love to continue the dialogue. Thank you very much.